Okay, let's integrate tangent of x. And though it looks quite harmless, and it seems like we should already know this, it actually doesn't come from the list of the basics we know from before. What we do know about tangent is its derivative. We also know the integral of secant squared goes to tangent x, so the things we do know are these two guys. We know that the derivative of tangent x is secant squared x, and we know that the integral of secant squared x dx is tangent x. But we don't really have on our list from before what the integral of tangent of x is. And also notice there's no powers involved where I can strip one out and put it as my du. So we just resort sometimes if you have a combination of trig functions that are not friendly together. By that I mean if it's not tangents and secants together or cotangents and cosecants together. Sometimes you resort back to changing things into sines and cosines to see what will happen then. So I'm going to go ahead and change this to sines and cosines. We do know that tangent is sine x over cosine x dx. And when we have things in terms of sines and cosines in an integral, that's useful too because we know sine as a derivative goes to cosine, and cosine's derivative goes to minus sine. So maybe we can manipulate this and do some form of a u substitution to our advantage. So if I try to manipulate this and do a u substitution and I just think it through, I have two options. I can either let u be the sine x or let u be the cosine x, hoping that my du will pick up the leftover. So if I let u be sine x, du does pick up a cosine x. However, notice the cosine x is in the denominator. What I really want is my du to be something nice, both pieces sitting in the numerator. So letting u be sine x does give me cosine x as popping out as part of my du. However, this cosine x is sitting in the denominator, not here with the dx. So let me try the other one. Let's say u is cosine x, because I know that's going to pick up some sine x business as well if I find my du. Du, cosine x, its derivative is minus sine x dx. Now that's nice because sine x dx, both of them get picked up from the numerator. So I go back and I resub everything. I end up with, I'll write it like this, 1 over cosine x, and then I'll write my sine x dx separately. And now it's pretty clear this guy is minus du from up here, and this guy is just going to be 1 over u. So I'm going to pull out the minus out in the front. I have 1 over u du. So it ended up being an integral that's manageable. We know what this goes to. The integral of 1 over u is just ln of u in absolute value, making sure the argument stays positive. And we had our u be cosine x in this case, so we end up with negative ln of cosine x plus c. This is one version you can use. The integral of tangent x is minus ln cosine x. So this is okay. But also remember log properties. If I have a times log b base b of c, if I want, I can actually use the log property and make this a an exponent, if you remember. So I can have log base b of c to the a if I want to. Or if I had an exponent there, I have the option of bringing it back to the front, whichever way it ends up being useful for me. So for this guy, this is, remember, a negative 1. I can choose to move the negative 1 up, and if I do that, I'm looking at ln of basically the reciprocal of cosine x. So we end up with 1 over cosine x, and that gives us secant x plus c. So all I did was take the negative 1 up as an exponent, and that's going to turn that into 1 over cosine x, and that's ln of secant x. So you may see both versions, both are acceptable.